All right. So William solved the equation for x and wrote the justification for his solution to each step. Okay. So when you're starting out an algebra proof, okay, or most of the time on a geometry proof, the first step is given because that's what they give to us. Now, what property is it when we do this? What algebra property was that? The distributive property. So we're given a justification. We're telling why they can do this in geometry. Well, it's given to us. Then we did this because we can do the distributive property. Now, when we move the 84 to the other side, what is that called? What do we do to each side? Subtract. So it's a subtraction property. And then 108 minus 84 is 24. What we would normally do is not even have this step in and call this subtraction. But since we said subtraction there, we do substitution here. Because we substituted the 24 for the 108 minus 84. And then the last step, what do we do to each side? Divide. So it's the division property. Okay, now see how subtraction and substitution both have sub at the start of them? So do not abbreviate subtraction as sub or substitution as sub because they could mean one or the other. So, vocab, a proof. A proof is a convincing argument using deductive reasoning. Vocab. Proof is a convincing argument using deductive reasoning. And what I did here is a two-column proof where the statements and the reasons are aligned in columns. So we have statements and we have reasons for each statement. Okay? So we have a proof, which is a convincing argument that uses deductive reasoning, and then a two-column proof where the statements and the reasons are aligned in columns. All right. So our first proof in geometry is that vertical angles are congruent. Okay? It's a theorem. It's our first theorem. So it would be theorem 1-1. Vertical angles are congruent. So angles that are opposite of each other are going to be the same size. And we're going to prove that they're congruent. Okay? To do this, and then here's your next vocab word. A theorem is a conjecture that is proven. A theorem is a conjecture that is proven. Okay, so I'm going to write a two-column proof proving that 1 and 2 are the same size. Now, given, so what we're given usually goes on the first line. So angle 1 and angle 2 are vertical angles because that is given to us. Then on the next step, I'll say angle 1 and angle 3 are a linear pair. And we'll learn about linear pairs in a little bit. And then I'll also say that angle 1 and angle 2 and angle 3 are a linear pair. And that'll be from the definition of a linear pair. And we'll define a linear pair in just a little bit, but what a little linear pair is two angles on the same line. Okay? So here's a line, angles 2 and 3 make up that line. And here's a line, angles 1 and 3 make up that line. Okay? So since they're a linear pair, angle 1 plus angle 3 equals 180 degrees. And angle 2 plus angle 3 equals 180 degrees. Okay? So that's all linear pairs sum to be 180 degrees. Hello. Okay, sounds good. Thanks. Bye. Carol, you need to pack up and go to the office because you have an appointment. So now, these two add up to 180, and these two add up to 180. So what we can do is, since they both equal 180, in step 4, I can say angle 1 plus angle 3 equals angle 2 plus angle 3. Because since they're both equal to 180, they must be equal to each other. Okay? They're both equal to 180, so they must equal each other. So I replaced the 180 in that one to angle 2 plus angle 3. So when you replace, it's called substitution. And then, step 5, we know angle 3 equals angle 3. Angle 3 equals angle 3 because that's what it is. And that's what we're going to call the reflexive property. And this is how we'll use the reflexive property. And we learned that we did have a reflexive property the other day, and now we're actually using it. Okay? So we know angle 3 equals angle 3. So if we take this line and subtract this line, 1 plus 3 minus 3 gives us what? Angle 1. And then 2 plus 3 minus 3 gives us angle 2. So angle 1 is equal to angle 2, so they're congruent to each other. So that's from subtraction that we can say 1 and 2 are congruent because of vertical angles. Okay? Because since these add up to 180, and we subtract off this angle because it's the same in each, that's why vertical angles always, always, always are congruent. Okay, here's another two-column proof. All right, it says, given angle 1 is congruent to angle 2, we want to say that all 4 of them are congruent to each other. Well, 1 is congruent to 2 because that's given. Why would 1 and 3 be congruent to each other? They're what types of angles? vertical angles because they're vertical angles. Okay? Why would 2 and 4 be congruent to each other? Because they are vertical angles. So since 1 is congruent to 2 and 1 is congruent to 3, 1, 2, and 3 are all congruent to each other. And since 2 is congruent to 4 and 1 is congruent to 2, 1, 2, and 4 are all congruent. So they're all 4 congruent to each other because of the transitive property, or I would say it's substitution. So either one works. Okay, the diagram shows how glass lenses change the direction of light rays passing through the telescope. Okay. What is the value of x of the angle formed by the outermost light rays of the focal point? So you're looking through here and you're looking out, and what happens is light rays come back in that your eye picks up. Now, if this is 11 degrees and this is 11 degrees, how big is this angle? It's 22 degrees. Why? Because they make vertical angles. This angle and this angle are equal because they're vertical angles, because they're opposite of each other, made by two lines that cross. So whenever you have two lines that cross, vertical angles are equal. So this angle must be 22 degrees. So to find what x is here, they are what types of angles? Vertical angles, so you set them equal to each other. So if 3x plus 31 equals 4x minus 13, how do we solve this? What's my first step in solving it? You learned from Algebra 1, Sawyer. Huh? Yeah, kind of supposed to pay attention when I'm talking. Yeah. So what is our first step when you solve that algebra equation? 3x plus 31, 4x minus 13. What do you move first? The 3x, the 31, the 4x, or the 13? You move the 3x because you want to always move the smaller variable. If you have variables on both sides, you want to move the smaller variable. Now, is that always? No. Because if you had like 5x plus 17 equals x, if x is all alone on this side, you're going to move the 5x to the other side. Okay? But if you have two variables and two numbers, you always want to move the smaller variable. 4x minus 3x is 1x. What you're left with is 31 on this side, negative 13 on this side. Okay, Shay, what's the next step? I want to get x alone. Add 13. So if we add 13, x is alone, and we get 44. So x must be 44 to make these two angles equal. Okay, more theorems. The congruent supplements theorem says if 1 and 2 are supplementary angles, and if 3 and 2 are supplementary angles, then 1 and 3 must be equal to each other because they're both equal to a different angle, just like what happened up here. Okay? Up here, 1 and 3 were equal, or 1 and 3 were supplementary, 2 and 3 were supplementary. So since 3 is its same angle, 1 and 2 must be equal. The same happens with supplementary angles and complementary angles. If 1 and 2 are complementary, which means they add up to 90 degrees, and 2 and 3 are complementary and they add up to 90 degrees, then 1 and 3 must be equal to each other because they both equal 2. Okay? So, supplementary add up to 180. You need to know that. Complementary add up to 90. Okay? So, what we're going to do now is a paragraph proof. And a paragraph proof is, instead of being written in columns, statements and reasons are connected in sentences. All right. So the paragraph proof for the congruent supplements theorem. By the definition of supplementary angles, 1 and 2 add up to 180. And 2 and 3 add up to 180. So since these two add up to 180 and these two add up to 180, their sums equal 180. So we can basically set them equal to each other. 1 plus 2 and 2 plus 3 are equal to each other because they're both equal to 180. So if we subtract angle 2 from each side of the equation, we're left with 1 is equal to 3. So then by the definition of congruent angles, 1 is congruent to 3. Okay, so that's using a paragraph instead of columns. The next theorem is all right angles are congruent. Okay, all right angles are 90 degrees, so they're all going to be congruent to each other. Then theorem 1.5 says if two angles add up to be 180 and they're equal to each other, they both have to be right angles. Because the only two angles that are both equal and add up to 180 are 90-degree angles. And what's another name for a 90-degree angle? A right angle. Okay. All right. So a linear pair, the sum of measures of a linear pair is always 180. Okay. So when you have two angles that are on a straight line, they're always going to add up to 180. So they're always going to be supplementary. So linear pairs, and this is what a linear pair is, are two angles that are on a straight line. They always are going to add up to 180. So we're given that angle 1 is equal to angle 2. These two angles are equal. And we're also given angle 1 is 105 degrees. We're going to prove that angle 3 down here is 75 degrees. So the first statement, 1 and 2 are congruent to each other. What's the reason for saying that? Well, if they're in our list of givens, it is given. Okay. Angle 1 is 105. Where do you see that? In our list of givens, so it is given. Okay. Angle 2 is 105. Well, if angle 1 is 105 and 1 and 2 are equal, then angle 2 must be 105 by the transitive property. If you said substitution there, you'd be just fine. I'm fine with saying substitution. But the transitive property is this. If this equals 105 and this are equal, then this equals 105. Okay, kind of like the law of syllogism. Okay, now 2 and 3 make a linear pair. Why? Well, from the picture, we can see that they make a linear pair. That's the definition of a linear pair when they're on a straight line. So all linear pairs are 180 degrees from the linear pair theorem. Linear pairs always add up to 180 degrees, okay, from the linear pairs theorem. And so we're going to replace the angle 2 right here with 105 degrees because of this. Because we said 102 was 105, so we'll replace it. So when we replace it, it's substitution. Then if we subtract 105 from each side, we get angle 3 equals 75. Well, that's the subtraction property. So that's what proofs look like. Okay? You could have a 2-column proof or you could have a paragraph proof. But that's what proofs will look like. Okay? So I'm going to assign a Savas out to you. And then before lunch, you will work on that. We are still the second bell. Okay, we were a second bell last week. We're second bell this week. And then the next 2 weeks after this will be first bell again. Yeah, sign out.